3.3. Specifically, this is 3.3 problems for both one proportion and one mean using a theory-based approach. So this is the summary page I just want to point you to, sort of broken into two parts. Here's my proportion, here's my quantitative sort of game plan. All right, so of course, if we have categorical data, we have pi. We read our null hypothesis. Here's my null. Pi equals some value. For my alternative, I have pi, and here's my three choices based upon what the problem is asking me. So it can be there less than, greater than, not equal to that same value. To use a theory-based approach for a categorical set of data, we need to make sure that the number of successes is greater than or equal to 10 and the number of failure is greater than or equal to 10. So our sample size n is equal to the number of successes plus the number of failures. All right, so if we have a total sample size of n, successes plus failures equals the total sample size. All right, so when we're doing the theory-based approach, we've got a normal distribution. So some problems are going to ask us to calculate this by hand, or we can use the applet. They both really result in the same thing, but you need to know how to do it both ways. So the center is always going to be equal to whatever this value is in your null hypothesis. We can calculate the standard deviation of the distribution, also called the standard error, SE, by taking the square root of this whole thing, pi times 1 minus pi divided by n. The z-score, we have a z-score when we're talking about categorical data, also called the standardized statistic. We can calculate that, or the applet calculates it, by taking our observed statistic, p hat, minus the center or the mean of the distribution. In this case, it's exactly equal to our null. So it's pi divided by the standard deviation of the distribution, which is just what we calculated up here. If I put it in the applet, here's the input. All right, so we would put our sample size right here in this box. This count wants you to put in the number of successes, and of course the p hat just wants you to put the p hat in. We're going to make sure that we select test of significance in the applet. And then these boxes here, we need to make sure that we put in exactly what we have for our null and our alternative hypothesis. So this here is going to have to either have the sign less than, greater than, not equal to, and the values we put in here need to match our null. All right. And then the applet is going to calculate the p-value and the z-score. There'll be links to these applets here that I will post as well. All right, same thing on the mean. We have one mean. Our null is mu equals that value. Our alternative is we select one of these options. It's either less than, greater than, not equal to that same value. All right, the validity conditions we need to meet to use the theory-based approach means our sample size n has to be greater than 20. All right, we need to determine, are we going to calculate it by hand or use the applet? Both are going to result in the same distribution. The center or the mean of the distribution is going to be at mu equals whatever this value is. We can calculate the standard error, the standard deviation of the distribution, by either putting sigma, that's the standard deviation of the population, or S, the standard deviation of the sample, divided by the square root of n. And when we're dealing with quantitative data, we're dealing with a t-distribution. So a t-score, also known as the standardized statistic, we take our observed statistic minus the mean of the distribution, which is just equal to this, mu, divided by the standard deviation of the distribution, which we calculated here. In the applet, a little bit different input. We're going to put the sample size here. We're going to put our x bar, the sample mean, in this box, and then we're going to enter our standard deviation of the sample or the population if given. And again, this needs to match, these boxes here need to match whatever our null hypothesis is in our alternative. So this is going to either be less than, greater than, not equal to, and there'll be links to the applet. All right, let's do a couple examples. This is from the homework. So we're given population parameter of mu equals 50.8, sigma, okay, this is the standard deviation of the population, is equal to 71.8, and we want to draw a random sample size of 101. What is the mean of the distribution of the sample means? They don't give us a lot of information here. It doesn't say use the applet, but here's the questions I want you to ask yourself. Is this categorical or quantitative? Well, we have a mu, so that means it's quantitative. We have a mu, which means the mean or the average of the sample. We don't know what kind of average, but we have mu, so it's quantitative. All right, do we meet the validity criteria to use the theory-based approach? Well, given we have quantitative data, if you use this as your reference sheet, this is what we need to meet. Is n greater than 20 and not skewed? Well, n is equal to 101, which is greater than 20, so yes, we can use a theory-based approach. Are we calculating by hand or using the applet? Well, it didn't say use the applet, so we're going to calculate it by hand. All right, we're using a t distribution because we have quantitative data. The center of that distribution is going to be at whatever our problem tells us. In this case, mu equals 50.8. The center is going to be at 50.8. And then we're going to calculate the standard error, the standard deviation of the distribution. Well, are we given a sigma or an S? Well, we were given a sigma, 71.8. So we're going to say, I'm going to put sigma 71.8 divided by the square root of n. N is 101 divided by 101. And that value there is going to be one standard deviation, which is 7.144. That's one standard deviation. What did the problem ask us? It said, what is the mean of the distribution? The mean of the distribution is just the center. The center is the mean, 50.8. The standard deviation of the distribution is just this value here, also called the standard error. Okay, we calculated it, 7.144. It wants it to 2 decimal places. That becomes 7.14. All right, let's do the next one. Here we have an election, and it says, suppose that 45% of the voters support the incumbent. We poll 210 people at random, and then we get a probability distribution. That's this curve here. That's how all of the data is distributed. All right. It can be modeled by this normal distribution. Complete the boxes to 2 decimal places. All right, so let's ask the first question. Is this categorical or quantitative? Well, does it say mean or average? No, there's a percent. That's a no. Do we have a proportion or a percent? Yes. That means we have categorical data. All right, that's important because in order to figure out the standard deviation, we calculate them differently for categorical versus quantitative. Do we meet the validity criteria to use theory-based approach? In general, I'd like you using this reference sheet here, okay? Number of successes greater than 10 and number of failures greater than or equal to 10. Okay. Well, that's what I put here. Number of successes. Well, how do I figure out the number of successes? I just have the total n equal to 210. How do I know what the number of successes are? Well, we also have this proportion of success. Okay, that's my pi. My proportion of success is 0.45. That's equal to my number of success divided by my sample size. To calculate the number of success, I need to do algebra. N times 0.45 equals number of success. My N is 210. 210 times 0.45 is equal to about 95. Okay, I have it down here. All right, the number of success is equal to the sample size times the proportion of success. That's equal to 210 times 0.45. All right, the number of success plus the number of failure equals my total sample size. So if the number of success is 95, I've got to have 95 plus some other number equals 210. Okay, if I solve for that, my number of failure is 115. So that does meet the criteria to use the theory-based approach. All right, are we calculating by hand or are we using the applet? Well, we don't have anything that says to use the applet, and they give us all the information, so we're going to calculate it by hand. How do I calculate it by hand? Well, the center of the distribution, or the mean of the distribution, is at pi equals whatever the value is. Pi equals 0.45. 0.45, that's going to go in the center. Okay? 0.45. I'm going to calculate the standard deviation, or also known as the standard error, using this formula here. Pi times 1 minus pi divided by n. That's equal to the square root of 0.45 times 1 minus 0.45 divided by n, which is 210. And that is equal to 0.03433. This is one standard deviation. That's one. We want 2 standard deviations. So we multiply that by 2. 2 standard deviations is 0.06866. If I round, that's 0.069. All right? Now let's fill in the distribution. So the center is at pi. That's the mean of the distribution, or the center. This would be 1 standard deviation. We want to go, this box is plus 2 standard deviations. Pi, 0.45, plus 2 standard deviations, 0.069. Gives us an answer of 0.52 if we round, because we want to round to 2 decimal places. This below the mean is subtracting 2 standard deviations. Minus 1, minus 2. We're going to take pi, the center, 0.45, minus 0.069 is going to give us 0.38. Okay, let's do one more example. Here we have, let x represent the full height of a certain species of tree. We assume that this has a normal probability distribution. That's this curve here, the normal bell curve. It has a mean of 109.1 feet, a standard deviation of 62. Okay, we intend to measure a random sample of n equals 143. All right, this curve is the distribution. There's a whole bunch of x bars here. All right, so we want to fill in these boxes. Here's the center. Here's 1 standard deviation. Here's plus 2. Here's minus 1, minus 2. All right, let's ask our questions. Is this categorical or quantitative? Well, we have here means. Okay, we have means. So that means we're dealing with quantitative data because we have means. Does it, so given we have quantitative data, does it meet the validity criteria? Well, to use the theory-based approach, we need a sample size greater than or equal to 20. Okay, n equals 143. Yes, that is greater than or equal to 20. It doesn't ask us to use the theory-based applet, so we want to calculate it by hand To calculate it by hand and fill the boxes in, we're going to use this information. Because it's quantitative, we have a t-distribution. The center, or the mean of that distribution, is going to be at mu equals whatever we have. Well, right here, we have mu equals 109.1. We have standard deviation, that's sigma of the population equals 62. These are feet. And we have our sample size, n equals 143. So we're going to use that. Mu is equal to 109.1. We're going to use sigma. So we've got sigma divided by square root of n. That's equal to 62 divided by the square root of 143. And that is equal to 5.19. This is one standard deviation. All right, we want to add 2 standard deviations. 2 times 5.19 is equal to 10.39. That is 2 standard deviations. So to fill this in, the center is going to be at mu, 109.1. We're going to add 2 standard deviations to mu, 109.1 plus 10.39. That's going to give me 119.49. Now to go find 2 standard deviations below, we subtract. 109.1 minus 10.39 is going to give us 98.71. That's what we have.